All right, welcome back. We are recording now. We are GAME3001, Artificial Intelligence for Games, in the winter 2022 semester at George Brown, and it's week 1, part 2 of our broadcast. And what we're talking about this week is, today is Lab 1. We're going to work around Lab 1. And what we're doing with Lab 1 is we're going to get to know the Sdl Engine. I'm just going to right now go up on Blackboard. And I'm going to copy our link so you guys, if some of you need support up online to watch this lab on YouTube, we can totally do that online. I'm going to do that here by creating a new link for it. And so you guys can watch it live. And bear with me while we do that. We're going to start just momentarily. Again, I apologize, starting a little bit late. Lab video. And we'll just put this, we'll pop this right underneath the other one. Okay, so there it is. Getting to know Sdl Engine. All right, so what we did last time when we got together was we kind of did an introduction to AI. We discussed our structure. We said that this week we're going to be talking about an intro to AI. We're also going to be talking about the assignment framework, version control, some game design patterns we're going to hit in lab. And then we also talked about how things are broken out. We said that all labs are 4%. We're going to hit about 11 out of 13 labs, so every lab really counts. There are no midterm tests or final tests in this course. That's why it's super important that you attend lab. That's what we said, and that's what we're going to go with. We also talked about lab reports, and I'm going to talk about the lab report that's been included in your up on Lab 1 right now. And so without further ado, let's download the engine. Now, when you want to download the Sdl Engine, there's a couple places you can get it. If you go to Assignments, you can see that there is the assignment framework here. I'm just going to close some of these links here so I can take you there and I can show you what that looks like. So again, here's the assignment framework with Sdl Engine. If I Control-click that, it'll open it up. And what I want you to do is download this code. There's two places to download it. You can download it here by clicking code and then download, or you can click it here and download it this way. Okay, both ways give you a zip archive that you can use to download and install the Sdl Engine we created for this particular class. Okay, that's number one. So, but we need a structure for where you're going to put it, and so the first thing that I'm going to say is, let's put it somewhere else. I have, and I believe you guys are you guys 402 or 400? I can't remember. 400. That's right. Alex has 402. So I'm going to make a brand new section. So new folder. And I'm going to call this section 400. So this is for you guys. And what I want to do is I want to grab a copy of this Sdl Engine master that I've kind of downloaded and put it inside of 400 just temporarily, paste. And I'm going to unzip it here. So I'm going to say 7-zip, unzip here, right? And it's going to create I'm going to just remove this from now. It's going to create an Sdl Engine master. And the first thing that I want you guys to do is change the name of this so it says something like Lab 1. There it is. There's Lab 1. Okay, so that's step 1. Are you with me? It's pretty straightforward. I want you to download the engine and install it here. Now, when I ask you, are you with me, I want you to do with me what we did before, which is I want to see check marks in Zoom. So please, when I say, are you with me, show me check marks in Zoom. You can go to reactions in Zoom and go check mark. I see Ethan is good. Okay. It's fine. So I see a bunch of you. So far you've done it. Please follow along with me because if you don't, I see one X. Jesse, what's the problem? You shouldn't see an X. It should be a check mark only. Just slow. It's okay. You can do it. I'm here. Melika has a check mark. I got 12 check marks out of 26. I'd like to see more than that, please. Okay, we're getting there. Maybe a couple more. All right, that's good. That's good. Thank you for that. I'm going to move on now. So we have our lab 1, and if you go into lab 1, let's talk about the file structure that you're getting. Again, today is all around the engine. I'm gonna go through details about how this whole thing works and a bunch of other stuff. So in the engine, you have in the operating system, notice that there is a template.sln file. All of our files are in a single location. If you look in the src folder, you can see that .h's and .cpps are all in here. Okay. And the lib folder includes all the lib files for SDL2. And the includes are all the libraries that I've included for you guys. And the bin files includes all of your DLLs to make SDL run properly. All right. So there's nothing for you to download or install. All told, this is about 1,000 files because of all the libraries that I've included. I'm not excluding them. And the reason why I'm not excluding your library is so that you can run this thing and not have a problem. It's kind of a self-contained structure for you. Okay. Let's double click on our template.sln file to start off. So double click template.sln. When you do this, the first thing you should do when you get here is change your hardware configuration or your solution platform from x64 to x86 because it's 32-bit that I made. All right, x86. And what you want to do, because my system is different than your system, and my version of Visual Studio is running on Windows 10 Pro, you want to retarget your solution. So I want you to right-click on your solution and go to Retarget Solution. Please do that every single time we're together. Visual Studio 2019, please. Not 2022. Okay, so I've retargeted my solution. You need to do that every single time. All right, great. Now that we have this, let's just run it. Let's just run the project and see what it looks like. So when I run the project, what you're going to get is a couple of things. It's going to take a second to build, right? And when we build the project, let's take a look. Going to take a second. And there we go. We have a screen that comes up, right, that says start scene, press 1 to play, and there's a little ship here and start, right? Notice when I hover over my mouse, it looks like a button. And if I click start, I go to the next scene, and this is the play scene, and I see a little plane and a little player that looks like Mega Man, right? And if I click next, it takes me to the end scene. Yay! If I go restart, it goes back to the play scene, and if I go back, it goes to the start scene. Notice also that what's happening here. Every single time I move from one scene to the other, it cleans up the previous scene. Also, if you press the backtick character, so that's the backtick character, this one, which is located just below your escape key, that is next to the tilde character. So it's not this character, it's not this one, all right? It's the backtick character, which is next to the tilde character. If you press the backtick character now while you're focused here, you're going to see a little other window come up. This is the IM GUI window. The IM GUI window stands for an immediate mode, immediate mode graphic user interface window, which means that every frame it's being updated, it's being redrawn. Okay? What IM GUI does for us, this little window, this little helper window, it allows us to troubleshoot our code. That's what it's going to help us do. And stress test our application by changing some properties in real time. That's what it allows us to do. And if you want to see all the widgets, this is kind of here in your IM GUI demo. This is kind of like the kitchen sink. It shows us all the different widgets that IM GUI, which is a library, what IM GUI gives us. Notice that there are buttons, right? And there are sliders, right? Down in here, here's some sliders. Okay, different kinds of sliders, checkboxes, trees, all kinds of stuff that it can give us, right? So a ton of tools that you can use to troubleshoot your application. Sorry, Malika, what do you mean by Apple? Oh, you mean this? Yeah, it just changes the name of the slider. It shouldn't say apple. I mean, if it does, oh, you mean apple, banana, cherry. Apple, banana. It's a pull down. That's what it does. So yeah, so that's what this thing does. All right. If I go to my start scene, if I press start and I go to my start scene, the IMGUI window changes, right? So that it has my button, which every time I click my button, you can see that it responds, as well as I can change my slider controls so that they go from a 0 to a 2, all right? Again, it's just an example slider that I've added for you. And we're going to modify this today, okay? Let's exit. Now there's 3 ways to exit the application. I can press escape. That exits the application, all right? I can also press X on the console window. That exits the application. And of course, I can press X on the window itself. That exits the application. Those 3 ways. But notice what it's doing is I have a window that's 800 by 600. It has a title in the title bar. It allows me to minimize, but it doesn't allow me to maximize, right? And I cannot stretch the window because I've made it so you cannot. If I click the start button, it takes me to my play scene and it gives you some instructions. By the way, these instructions are game objects that I've added in to the structure of the scenes. Let me talk about how the structure of this Sdl engine works before I go into the code. And I'm just going to close down this window and I'll re-explain all this in a second. So remember what Sdl Engine does from the stuff you've learned from before. Sdl Engine is based on SDL, which is single direct, the single direct layer to render things with you. That's all it is, right? Very simple API, and SDL2 is what we're using. What SDL2 does is it requires a couple things. It requires a window, right? And the window object is a container that contains everything that's inside of your code, right? So that's window. Window is a windowing system. You can use GLFW for windowing, WinAPI, and others that you can use to show a window on your screen. The good thing about SDL is it's cross-platform. WinAPI is very Windows-specific. GLFW is more for 3D, and there's others. Okay? So that's the window. So the window is an object, and it also has a pointer reference. That's what it does. Okay, that's what the window gives us. And inside the window, we also have a renderer. Okay? And the renderer is kind of like a canvas. That's how I see it. That's how I think about it. And it kind of sits within the window container like this. This is the renderer. Okay, so we have a window and we have a renderer. And the renderer is where all the fun happens. This is where everything is shown. Okay, this is SDL. Okay. So you have an SDL window and an SDL renderer, right? So whenever I want to create a window or a renderer, it doesn't update unless I tell it to. In order for me to update the window, I need to run some kind of while loop or something else that runs it. What I've created for you guys is a series of game objects and structures that we're going to be talking about today. One of them is the game object superclass. And I want to kind of put together all my classes here so you can see it. So I'm going to kind of at the top, I'm going to put a little box that says game object. Game object is basically a container that contains some properties. One property that all game objects have in Sdl Engine is a transform property. The transform property is actually a struct. All right, so it's a separate struct that's here that you're going to see. And this transform is going to include rotation, position, rotation, and scale. So this is what it is. These 3 properties. These 3 properties are actually of type GLM vec2. GLM vec2 is a vector2 object. Okay, that's what they are. Okay. And what is GLM? GLM is the graphics library, math library for OpenGL. We use it for a lot of other reasons, and I've included it here for you because, as an example, I want you guys to get used to using GLM because it's a fully fledged library that includes vector addition, vector subtraction. It also includes scaling, quaternions, and a bunch of other math functions like dot product, cross product, and a bunch of other stuff. So really great library to use for you when you're learning graphics, and whether it's 2D or 3D. So that's the transform. So the transform component isn't it's game object doesn't inherit from transform. It includes a transform component as an object. So really what we're talking about is it's composed of a transform component. We're also going to talk about, in brief, another component called a rigid body component, right? So it also has a rigid body component, which is another type of struct. Game object has a lot of other stuff. It has a lifecycle function, a bunch of lifecycle functions like a draw function, an update function, and a clean function, and a bunch of other stuff that it does for us. That's what the game object is. Remember that there are 3 types of game objects that you've learned about in game fundamentals. An object that updates only, an object that draws only, an object that draws and updates, okay? And for those type of objects, we're going to have another class that inherits from game object, okay? So I also want you to think about the game object class as an abstract class. Remember what an abstract class is. The game object class being abstract means you cannot instantiate an object of this type of class. As an example, it can only be used as a blueprint for other classes. So that means if I was going to kind of do the hierarchy, like again, if I was going to draw out the class structure properly without making mistakes like that, is I have another class that we can use called display object. The display object class is another abstract class, but it adds a little bit more functionality. It allows us to keep track of its parent, right? And it also has additional, kind of properties. It inherits from the game object superclass. So when it comes down to it, what we look at is something that looks like this. So if we're using UML diagrams, it kind of looks like something like this. So display object inherits from game object. Okay, let's take a pause for a second when we talk structures. What I'm going to do for you guys, and what I've done, is inside of the Sdl window, we're going to create another kind of class, which is the scene class. Here's our scene. Okay. And our scene class, right, inherits from game object. Okay, so I want you to understand that. So this is extends game object. Okay. Scene is also an abstract superclass, but what scene includes is something called a display list. And the scene's display list, right, gives us some functionality. Think about the display list as a vector of display objects, a vector being an array, a managed array. Let's just put it over here. So this is a display list, okay, which is a vector of display objects. That's what it is. Now we're talking about a C++ vector, not a vector 2. Okay. So a vector of display object, that means that it has to have a way, I have to give scene a way to add display objects. If I have things like a game object, like a player or a plane, or any of the things you've seen, we need to be able to add a display object to the scene. And the way we do that is through a function called addChild. You're going to see that function here. Okay. And we also have removeChild, of course, as another function. We can remove stuff from the scene. And we also have remove all children. And we also have a draw display list. So draw display list, which draws everything in the display list that gets added in, as well as something called update display list. Okay, so these are all the functionalities for the API. Okay, so this is interesting. So I can add child, and whenever I add child, I can kind of add it to the display list, right? So, for example, if I have a child that I want to add in, which is a ship, right? Let's suppose I add a ship to the display list, and let's say ship is a game object of some kind or display object. It has to be a display object, right? Then ship gets added to the display list over here. When I call the update function, which is update display list, ship is, if I move it around, it'll update its properties. And when I call the draw display list function, it will draw the ship inside the renderer. This structure is what you're going to see when I talk about the code. All right? Any questions around this so far? Again, it's very, very high level. I'm starting very, very high level. I'm going to work down to more of the nitty-gritty as we go. Any questions? Guys, for this to be good, please interact with me. If you don't ask questions, you won't understand. Jack's good. Anthony's good. Awesome. All right, thank you. Let's move on. Awesome, thank you guys. All right, so that's good. So if we know this, right, if we know that this is the way it's going, right, then when we look at our structure, what are these things called, guys, inside of Visual Studio? It's not a trick question, but some people get this wrong. What are these things called? Come on, take a crack at it. Worst case, you're wrong. Files. No, they're actually filters. Some people might call them folders, but they're incorrect. They're filters. All right, so I know. It's not a trick question. What it is remember that all of our files in the operating system are housed inside of the SRC folder, right? But when we look at them in Visual Studio, it's not what you see is what you get. They're actually filtered within different little organizational containers here, but they're not real. They're just for us so that we can organize our files, okay? We start in the core folder. This is where we start our story, in the core folder. And we go into the main.cpp. Let's take a look at that. So in the main.cpp, we have an object or a window that gets created here. And let's talk how this gets created, starting from the main. First, we set our FPS or our frame rate to 60 frames per second. Our delay time is a global variable as well that we set to 1000 divided by FPS, which works out to be 16.6666 milliseconds. All right, it's not what you're expecting. And what we have, once we have these two kind of properties or values that are floating around, we can use these to do stuff. And when we scroll down, we see some other things that we've set up, a frame start and a frame time, a number of frames to initialize with. And when we get to alloc console, this comes from the crtdebug.h file. That's what it comes from, which allocates our console so we can show our console to the screen. And then we get to this one, and then people start getting confused. They're like, wait, what is this? The game instance init. This, my friends, is the way we start our game off. This is a singleton. Okay. So what is a singleton? Well, it is a design pattern. And this is the first design pattern we're talking about today. Remember we said that we're going to talk about a couple of design patterns here. And one of the design patterns is this singleton design pattern. What is it? The singleton design pattern is good and bad. What it does is it gives us a single point of access to a particular class or object that you only want it to be created once. So I don't want to instantiate my game more than one time. So therefore, the thought is you make it a singleton, a single instance of the class that can be created at any time. And at the same time, this is the second thing that it can do, it's somewhere you can access it globally. Now, because it's doing two different things, you're making a single access point as well as a single instance, you're violating something called the single responsibility principle. Most programmers will tell you, if you learn about the solid design principles, that the single responsibility principle states that you can have one class that does a single thing at any one time, or one function that does one thing at any one time. You don't want a function or a class to do multiple things. If it does multiple things or serves multiple purposes, it's violating the single responsibility principle, which is what singletons do. So they're positive and negative. If you have too many singletons, right, then it's like having global variables everywhere. If you have a few singletons, what it does is it prevents users from accidentally instantiating multiple instances of the game class. Or, like we said earlier, I only need one window, right, for SDL. I only need one renderer for SDL. So those are also singletons, okay? Another great use of singletons is managers. If I want to manage a group of textures and I want to hold textures in memory, I only need one texture manager. I only need one audio manager. I only need one event manager. So those are all singletons. If you see inside of our folder structure, singletons are all housed here. So the game is a singleton. The IMGUI window frame, which allows us to show that second window, that's a singleton. The render is a singleton, okay? And the other things that are singletons are anything that's pretty much inside managers. So collision manager, as an example, it's either a singleton as a manager or it's a static class. So collision manager, event manager, font manager, sound manager, and texture manager are either singletons or static classes. The difference between singleton and a static class is that a singleton has an entry point, okay? And the entry point is usually the instance function. Now let's go there for a second and check out the game singleton. Go to definition. And by the way, while we're doing that, you might notice that the way my Visual Studio 2019 looks is very different than the way your Visual Studio 2019 looks. Well, there's a couple of reasons for this. One, I'm using the Resharper extension. We talked about this earlier. I highly recommend you go to JetBrains Education, which is this link. I'll put that in the chat right now. And I'll also put it on YouTube for those people watching on YouTube. And this JetBrains Education gets your free license. And what it does, they are a tool company. And if you go to developer tools, you can see that they have something called Resharper. And Resharper is Resharper Ultimate, okay? And it's a extension for both C++ as well as for C#. And what it does is it gives you code hinting for C++ and C#. It's good to get Resharper Ultimate because if you get Resharper Ultimate later on when you're using Unity, not now, but maybe in the future at George Brown, you'll get code hinting support, as well as when you're doing C++ code, you'll get code hinting and code coloring support that's different than the standard stuff you get from Microsoft for Visual Studio 2019. Hopefully this is helping you. All right, so that is why some of the things that you see here are colored differently, and there's some different suggestions here, these green underlines, that make some suggestions to me that you might not see. Okay, so I'm in the game.h and I see an instance function. So I want to redraw this thing. So we know about this stuff. Let's get back to this later on, right? I'm going to make a new object. We'll redraw it if we have to. But I want you to think about what a singleton is. So a singleton, let's suppose we have a class, right? We have a single point of access for the singleton called the instance function. There's my instance function, right? And this is usually public and static. All right, so this is public static, okay? And what it returns is an instance, a static instance of the object itself. So returns static instance. That's what it does. So every time we go to the instance, function, right? This instance function right now, it always returns a static instance. When we go there for the first time, it makes a new one, okay? So if the instance doesn't exist, right? If instance is equal to null, right? then make one. We'll say then create new instance, right? Otherwise, if the instance is not equal to null, if the instance already exists, just return the one you already have. So what does this do? It always returns the same instance, the same pointer in memory to something that we've created. So we can only ever create one instance of an object. That's what it does. So it's a public static instance function. That's what it is. Every time you see the instance keyword, I want you to think about it in our Sdl engine that it's a singleton function. What else do we know about singletons, right? This is a singleton. You cannot instantiate a singleton at all through the constructor. The constructor is actually private. So we have a private constructor, and we also have a private destructor. Okay, that's something to note. Okay, it's not public, which means you cannot use the constructor function at all. So why do we do this? Because we want to limit or constrain the user to going through the instance function for everything else they do. When we call a singleton, we call it like this, whatever the name of the singleton is. Hey, singleton. It could be game, texture manager, whatever. Replace singleton, whatever. Colon, whatever the name of the singleton is, the class. We'll say singleton class. Right? And then we call the instance function. And then from there, we call whatever other function we want to do in it. Okay, this is the example of how we would call the init function from the singleton class, right? And let's suppose the init function is another structure. Okay, there's another structure in here. Let's put it in here. Here's another function. Okay, so we'll call this the init function, right? Or some other function. It could be some function, whatever this some function is, right? And when I want to call init, I need to go through the instance function in order for me to get to the init function. I cannot access the init function directly. It's not a static class, it's a singleton. Questions around this structure? You're going to see it everywhere in the code. And I don't want you to be freaked out about it. All right, so I've talked to you about why we do it. Now let's show you where it's done. So there's your instance. It returns a reference to a new game instance, a static instance that we return out. It's public and static. And like I said, in the private area, we see both the constructor and the destructor. They're both private, which means they're inaccessible, typically. Also, a note about coding style. M_B means member variable, private for underscore, B for Boolean. M_B. M_P is member variable, private pointer. So window is a private member variable, pointer member variable, that we're going to have here inside of the game function. One thing to note is we're using shared pointers. So there's actually two types of pointers, major types. One is a raw pointer that we've talked about before. You've probably learned about it in your C++ classes, right? And there's also something called a shared pointer or smart pointer. Smart pointers allow us to memory manage a little easier than raw pointers, where we have to do all the memory management on our own. Okay? If we don't memory manage a raw pointer properly, we can get a memory leak, which is what we want to avoid. So I'm using shared pointers for our window, and for our renderer, and for our texture manager, and. Please don't change the type here from a storage perspective. Leave it alone. All right, great. So that is the .h. Notice also that all of our files have both .h and .cpp components. We don't run just one file for everything. There's just not one CPP file for everything. Other than the main.cpp, everything else is a .h and a .cpp component. Also, I have to mention that the other place that's individual is our enumerations. We have a bunch of enumerations that we've created. They're just .h's. But for the most part, it's both .h and .cpp. We're making it so that the type def makes it so you can say the game. So you know when I say the game, it's like the singleton. There's only one game. You don't have to use that. You can just go game, : whatever. But it's for you to remember that the game is a singleton and there's only one game. You don't have to do it this way. All right, so that's great. So we have our singleton and we have a bunch of things that are happening in the game. We have two of these functions, an init and another init. What are these functions called if they're the same name but different return types and parameters? What is this structuring called? Same name, different return types, different parameters. What is this called? Guys, help me out. Stanislav says overloaded. Absolutely. That's absolutely true. It's an overloaded set of functions. Init is an overloaded function that has two different signature types. Again, this should be all review for you so far, other than the singletons and the structures. That's all our own. One of the biggest challenges when it comes to looking at somebody else's code is understanding the why behind it. Why did Tom and Alex put together this structure for you? Why is it done this way? Could it have been done a different way? The answer is probably yes. There's a lot of different ways to do the same things. We've chosen to do it this way because it made sense to us, right? A couple things to note is that the game itself, which is a singleton, has several lifecycle functions. Lifecycle functions are functions that are carried through the entire application. So it has a render function, an update function, a handle events function, a clean function, a start function, and a quit function. And these functions, for the most part, are mirrored in all the game objects and scenes that you see in the game. Okay, just letting you know. So back to main. Main says, hey, get to the game, go through the instance singleton function, access the init function, pass in some information to the init function, tell the window where to start at 100, 100, x and y coordinates, make it 800 by 600, and do not make it full screen. And if you went there, if you went to go to definition, you can see that this definition of the init does exactly that. It takes a title, x and y coordinates, width and height, and is it full screen or not? Boolean. By default, it is not full screen. All right, great. So that's what it does. So this init function, what it does is it finally initializes SDL. And it goes through and uses SDL init, which is part of the API, right? It says that we're going to initialize everything. It makes a couple of resources. One of them is the window resources, which is a shared pointer, right? Stores it inside the window. When that's successful, it creates a shared pointer for the renderer. And then it goes through this. It kind of stores the renderer reference into something called renderer instance. What is this? Another singleton. So if you look inside the singletons, we have the renderer, and the renderer singleton is just a class that basically stores the renderer information as a shared pointer. So the reason why we've done it this way is so you can access the renderer from any point in your code, and you don't have to go through the game to get it, which is like, I need to go to the game, get renderer, and then do something with the renderer. We don't want that. We're using the renderer a lot, so we want to avoid going through the game to get it. We just want to get the renderer directly. And that's why we've created a singleton. Finally, if the renderer is good, we kind of say that let's set the render draw color to white. That's the background of the screen by default. And then we initialize the IMGUI window, that second window that you saw earlier. We initialize true type font functionality in SDL, and then we call the start function. If I go to the start function, go to definition, you can see that it basically sets up something called the current scene state, and scene state uses a scene state enumeration. Here's the scene state enumeration, where there are different kinds of scene states. The no scene is equal to -1, start scene is 0, play scene is 1, and so on. And we can kind of calculate the number of scenes by hovering this hack, which is num of scenes, which is number 3. So 3 scenes. If I added another scene, num of scenes would be pushed down, so that would be number 4, 5, 6, and so on. This enumeration is a simple enumeration. We're not using class enums or enum classes. It's just a single enum, so be careful. This is in the global namespace, right? Okay, going back. So it says in the start function that my m_current scene state, m means the private member variable that is of type scene state, starts off with no scene. And then we call the change scene state function and start the start scene. So let's go to that, go to definition. We go to the change scene state function. We take the new scene, whatever that is, and we use a switch case method to instantiate a new scene of different type: start scene, play scene, end scene, depending on what we pass in. In the beginning, we start with a start scene. There's my start scene. And I say the start scene itself, we set the current scene to a new start scene. When we use the new keyword, what we're doing is we're allocating memory on the heap, and we're returning a pointer to the new start scene object. Whoa. What is a scene? We said it. A scene extends the GameObject superclass. Where do I find that information? Right here. Here's our scene class. Our scene class, right, extends a public GameObject. GameObject being the, if I go to definition, GameObject is a abstract superclass. How do I know it's abstract? Well, we have a virtual destructor as well as several pure virtual functions. The draw, update, and clean functions are pure virtuals. If we have pure virtual functions and a virtual destructor, the class becomes abstract, right? Abstract classes cannot be instantiated, all right? They just use as blueprint classes, like we said before. So when I go back to this, the scene class inherits from the GameObject superclass, but the scene class itself is an abstract class, as you can see. It also has pure virtual functions and a virtual destructor. Okay, cool. So how do I then create a scene? Well, if I go down, I have to make a scene, a concrete scene class. That's how we've done it. And the concrete scene classes are start scene, play scene, and end scene. Let's go to the start scene. The start scene is final. That means it's a leaf class. It cannot be inherited from. It extends a public scene class, and it does not have a virtual destructor or pure virtual functions, which means it's something that you can construct. I can construct the start scene. And going back to my game, that's exactly what I'm doing here. I'm constructing a new start scene. I'm saving a reference to it, a pointer reference in m_current scene. Remember what we talked about. The start scene is going to be displayed within the renderer, and it's just a container that contains a display list, right? Okay. So that's what the start scene is. So if I run this thing, when I'm running it, when I have this scene that comes up, this start scene, I'm getting a pointer to a new scene object of type start scene. The start scene is a container that contains other objects. It contains a couple of labels, the ship, as well as this button. And to see that in play, let's take a look at the start scene. The start scene is exactly that. It has a couple of labels, the ship, and a button. What are labels? What's a ship? And what's a button? Let's take a look. So go to definition. The label is a final class. That means it can be instantiated but cannot be extended. And it inherits from a public UI control. What the heck is a UI control? Go to definition. Well, a UI control extends a public display object. Remember display object? Display object is actually inherits from GameObject and allows me to add stuff to the display list. So really, a UI control is a display object, which means I can add it to the display list, right? Also, UI controls are abstract, which means you cannot instantiate an object of type UI control, but rather you can inherit from it and create a specific type of UI, in this case, a label. Okay? And a label has a label constructor, which you can pass in the string, a font name, font size, font color, and a position, a GLM vec2 position that you can pass into the label to tell it where to begin. One thing to note, for all of our objects in the scene, I'm just going to go back to here. All of our objects, all of our game objects that we have, has a center point. Okay, so if this is the game object, we made a rectangle, then there's two ways you can make it so that the center point of the object is its x and y coordinates, or that's the default, by the way, or you can choose to change it to the top left corner of the screen of the game object. It's up to you. By default, it's the center. And that means when I add an object to the scene through the addChild function, remember we add an object through the addChild function, right? When we add an object to the addChild function, it must be a display object. That's what it needs to be, right? This object must be a display object or inherit from it. And it's going to be listed inside of the display list. And then we can update it and draw it. Okay, that's what we're going to do. So going back to this, right? When we look at our label then, our label actually tells us that the position of the label is going to be the default 0, point for glmvec2. glmvec2, remember, is a vector2 object that contains x and y coordinates. It's kind of like a templated struct that allows me to have integer types, float types, double types, whatever you want to make this vec2. And we can change our font style to whatever we want, whether it's bold or normal. And we can also decide on if it's centered or not. And by default, it's true. It's always centered. So that's what our label is. Our label is a game object, a specialized form of display object, which we call UI control, and it can be added to the display list. But remember what we do when we add a label. It's not like a label in Word. Okay, it's not like I can highlight this thing. Look at this. I can't highlight it. I can't select it. Why? Because the label is not actually text. It's rasterized text. That means I've taken a font and converted it to pixels. That's what this is. It's like bitmap fonts is what I'm using here in the scene. It's different than this. Okay. So that's a label, and that's one type of UI control. For UI controls, you can look at UI objects, which are down here. There's two of them. There's a button and a label. Those are both UI objects. A button is another type of UI control. And when you instantiate an object of type button, you have to give it the asset that you're loading in. That's the asset path. So for example, the start button, the button name, whatever that is, the game object type. By the way, game object type, go to definition. I have several game object types that I've included for you. And what we're using the enum for is for identification purposes, when I want to compare one game object with another. All right? And that is the game object type. It also has a default position, and it's by default, it's also centered. All buttons, all labels. Cool. Okay, let's back up, back up, back up. Back to the start scene. So the start scene has one button and two labels and a ship. Oh man, what's a ship? Go to definition. A ship is a object that is of type agent. What? What's an agent? Go to definition. An agent is a specialized display object. And of course, we're going to be talking about agents this semester because this course is about AI, right? And we've been talking about, last day we said, we're going to be talking about autonomous agents, and the autonomous agents are going to be running around the screen and having some kind of decision-making power or pathfinding ability, which is what we're going to ask you to do starting next week. We're going to get you to, start working on your first assignment. Okay, so that's what an agent is. It has additional structures. So all agents have that. All agents have kind of like to help us with pathfinding. That's what it does, and with other things. So that's what a ship is. And a ship is a specialized form of display object, which means I can add it to the display list. Awesome. So that's what this stuff is. Okay, so what about our lab today? What are we doing? And this is the stuff we have to start learning. We're going to learn by doing, guys. And one thing that Alex has done is he's put together a little checklist of things that he wants you to do. All right, and we're going to do this stuff. So the first thing is, we said create a master 3001 labs repo. I did mine and I called it GAME3001. And I have two subfolders, 401 and 400. That's for you. For you, this would be your master GAME3001 labs right here. Okay. I've downloaded the zip and put it into the GAME3001 labs folder, which is this zip, and I've extracted it and changed the name. I've changed mine to lab 1. So lab 1 or week 1 is okay. Okay. And then I deleted the zip. Okay. Now, what we want to do when we upload this to, before we start, we want to upload this to GitHub. And there's a couple ways to do this. Alex likes to use GitHub Desktop. So desktop.github.com, which is a free download that you can use. All right, so there's several different tools. Desktop, GitHub Desktop. There's also SourceTree. That's a very popular UI for Git for Windows. Okay, SourceTree. And the one I like to use is Gitkraken. The problem with Gitkraken, right? The problem with Gitkraken is it does not allow you to make private repositories, right, for online. It only allows you to make public repositories unless you pay. So if you say try free, you can try free for a bit, as an example, or you can also pay. And if you pay, let's go to how much it'll cost. If you pay, I think it costs like $5 a month or something like that. Now, again, you don't have to, to try for free, but it's a great little, thing to use if you're making public repositories. You guys aren't. So what Alex recommends is using desktop, GitHub Desktop, all right? What GitHub Desktop does is a UI for Git, so you don't have to learn Git commands on the command line, all right? And it's pretty simple how it works. In the previous section, I used Gitkraken to start off, and I'm going to finish with GitHub Desktop this time around. All right, let's talk about GitHub Desktop. So I'm going to download this just like you should. Let's do it. So there's GitHub Desktop. And I'm just going to close down Gitkraken. And let's run it. And one day, when it feels like it, it's going to run. There it is. And it says sign in. I highly recommend you do that here. Okay. And I'm going to do this off screen because I want to put my credentials in there. You can do the same thing for you. And then it says, after you're signed in, it says, let's get started. Now, the only way you can sign in is if you have a GitHub account. So if you don't have a GitHub account by now, please do so right away. Okay. So a couple things I can do. I can create a tutorial repository. No. I can clone a repository from the internet. No. Or I can create a new repository on your hard drive. Yes. Let's do that. And it's asking me what the repository name is going to be and where it's going to be. Let's point to where I want it. So I'm going to go to my desktop for me. And I'm going to go into GBC, GAME3001, section 401. Or 400, sorry, 400 for you guys, right? There we go. And then click Select Folder. So that is the local path, and we can give it a name. The name for the repository. Now, one thing to note is if you go right into 401, 401 basically gives you all the repositories inside of it. All the labs are going to be layered inside of it. We're going to have several labs in a containing folder, right? So the repository name should be something like GAME3001 in the winter 2022. And in your case, it's going to be GAME3001 labs, and then this is for section 401. Okay, I believe it's 401. Or is it 400? Is it 400 or 401, guys? I keep forgetting. 400. Okay, sorry about that. Let's just point to the right one. Okay, I was right the first time. Hey, okay, so 40400. Okay, this is what it's called. It's asking you for a git ignore file and a license. And if I click create repository, it's going to do that. All right, create repository. Let's take a look and see what it did locally. So I'm going to go back to my repo here, and it did this. Oh man, what the heck? Is this what we wanted? It's kind of empty in here. And the answer is no, we don't want this. What we want instead is to create a repository in our existing 400 file right here. So if you get that and you get this, it's incorrect. Let's go back and go back to, we want to change this or undo this, right? So, and this is, I'll be honest with you, this is why I kind of do things by hand, because a lot of times it's, again, not really that great, okay? So don't worry about it. We can add a new repository like before. We can remove it if we don't want to. We can remove it, okay? Yes, remove. And if you go here, if I remove this, let's try this again. So let's get rid of it. And I want to look at section 400 as where we want to go. Let's try it again. So again, I want to, now this is something, it says add an existing repository from your hard drive. That's a different option. Let's go and create a new repository again. So create a new repository. It's pointing in the right place in section 400, but this time I'm going to go here into where it says GAME3001, the containing folder. Cool. And instead of what the repository name is going to be, I'm going to choose the repository name as section 400 without pressing select folder. So that's going to be up here, the same name. And it says something for us right away. It says that, whoa, it says it will be created as section -400. Why is that? Because unfortunately, my friends, what, Git Desktop doesn't like section space at all. Doesn't like that. I made it section space, but you shouldn't. And of course you won't. You just make it something else. What you have to do before we continue, let's close this off for now because we can't modify the folder structure. I'm showing you the errors that you can go through. I've made some errors. You're probably going to make the same errors. Don't worry about it. They're correctable. I can go here and just change this to section -400. That's no problem. And if I try that, it's going to say, Matt, it can't. Why? Because even though I've closed off Visual Studio, it's still, some files are still open, right? So that's a problem. It says sync pending. Why? Because I've actually got OneDrive working in the background, and that's what's causing me to have an issue. It's trying to sync my stuff. So let's close OneDrive, and let's close OneDrive here too. So I don't have any OneDrives open. And let's try that again. Let's try and go here and change the value from this to -400, right? And let's see if it does that. There's -400 now. Yay, we can always re-energize OneDrive again if we want to, right? Not a problem. Okay. So that's cool. I like it. But how does GitHub Desktop work with it? Let's go back. And I want to create a new repository. Again, just like we did before, we're searching for GAME3001, and I want to create it here. So I want to click onto it, copy it, and cancel. I don't want to actually create it there, and put that in the repository name up here, and choose Create Repository. Whew. Finally, it's made the repository for me, but it did something else. It made its own repository again that's empty. Look at that. Section 400, section 400. Man, it's killing me. And this is why I don't like these tools at all. Let's fix this up again. Let's go back. And let's go back to here. And I want to remove it. Cool. And let's fix that problem. It's this one I want, not this one. Let's delete this one. Delete. One more time. I love this one. In a second, I'm going to do everything by hand because I can do it 10 times faster by hand. Okay, let's look at this and see where it's pointing. GAME3001, select folder. And I want to look inside of that section 400, right? Section -400 area right there, right? Let's create repository. Will it do it again? No, thank God. Cool. Finally, it's working. That's just me, so it's my errors. Awesome. Excellent. It looks like it worked, right? And let's see if it did it like it's supposed to. Here's section 400. Hey, look at that. I got a Git repository and a Git attributes file. Perfect, right? And in section 401, we've got it, but it's from your other classes. That's cool. Here's section 400. That's you guys. Awesome. So what I want to do now is I want to publish this repository. How do I publish it, right? Well, it says publish repository up there. Okay, it tells me the name that it's going to be. It's going to be on github.com, the description, and any organization. I'm going to choose my organization, right? That's you guys, right? And I can change the name of the repository to whatever I want. So here I'm going to change it to GAME3001 in the winter 2022 semester. And it's going to be labs for section 400. And it says publish repository. Now, for the first time when you publish a repository, it may ask you to log into GitHub for the first time. Okay? It may ask you to do that. Let's take a look online and see what it did for us. So I'm going to go back on georgebrown.college.com, and you're going to see, hey, there's my section 400 repository, but it's private by default. So this is really great for you. What you need to do, I'm going to make it public in a second, but what you need to do is you need to go into your section 400 repository, and you need to include myself and Alex. The way to do that is you're going to go into settings, and you're going to go into collaborators and teams, and down where it says add people, you're going to add me and Alex. So first let's add Alex. So we're going to say for Alex, you're going to add in the professor, right? Him. That's a way of getting to him. And then make it so that he has read access, right? If you want. Or in this case, it's forcing you to have a write role. That's fine. Let's add that in. Let's add him in. Okay, he's going to get an email that says, hey, I've given you access, right? And let's add me in. So I'll say add people. And when you're doing this together with me, you're going to search me up with my last name, just my last name. Now there's two of me, okay? There's this one, and there's this one. And there's also some other dude, George. That's not me, okay? It's this one, just my last name is what you want to look at. If you don't know who I am, you can always go Siliopoulos@hotmail.com, and that'll zero into who I am. That's the one I want you to use. And I'll copy and paste this on the chat so you can include me. Please do that. Okay, that's the one. And when you do that, I'll be added in to the repository. Okay, that's what it'll do. All right. Now, what about if I want to make, me personally, if I want to make this repository public, which it should be for you guys so you can see it. Well, if I want to make the repository public, then I can manage access. And in manage access, I can change the visibility. It's going to ask me to log in and put all this stuff in here. So the name of the repository, copy, paste. And I'm going to say, I understand, change repository visibility. So when I do that, all of a sudden, right, it's going to change. I want to make it public, right? So I kind of changed it to public. Let's try that again. So manage, I want to change the visibility, and I want to make it public. The current repository is private, right? So I want to change the visibility to public. I'll be okay, Tom. And then put that in there. And then press change and understand. And what that does, you can shift anytime from public to private and from private to public. On GitHub, it's free to do either one for you. Okay? For me, I need to be public so you can see my repositories. For you, you need to be private and only include myself and Alex. Okay? Okay, this is great. That's awesome. And it shows you that I have lab 1 and all my stuff. But it also has a couple things. I want to add a Readme file that tells me this is your lab 1. So how would I do that? I'm going to click add Readme file up on GitHub. And I'm going to go in here and say something like, this is a the lab repository for GAME3001 in the winter 2022 semester at George Brown. Okay? You can actually say lab repository if you want. Lab repository for GAME3001, blah, blah, blah. And I also should probably say for section 400. That's you guys. And click commit new file. Now, when I do that, when I commit a new file here and I have a new README file, I'm one commit ahead of my local repository. And so what I need to do is pull. So if I go back into my local repository in Github Desktop, right? Then notice that I have some commands here and it says fetch origin. When I fetch an origin, it says, hey, pull one commit from the origin remote. Let's pull. Hey, and now I'm up to date again. One thing to note is you can look at history. So these are all the history of all the files that you've done. You can see all the commits here, an initial commit and a README file. You can see that in history. And any changes that you make are going to be made locally. So local changes and the history. Pretty cool. The current branch, you can fetch the origin and it tells you what the current repository is and where is it. Excellent. Let's relaunch Visual Studio. Are you with me? Check mark if you're with me, X if you're not. Hopefully this will fix the other section as well. So GitKraken only produces, like we said, public repository. GitHub Desktop supports private repositories as well, and it's not so bad. Thank you for that feedback. All right, so this is cool. Let's relaunch my project. So again, I'm going to go back into my project, into Lab 1, and double-click on Template SLN and relaunch. Awesome. Okay, so now that I've got this going, anytime I add a change to my project, we can upload it from GitHub. What we want from you is multiple, commits, one every time you do a feature. That's what we're looking at. Let's try this now. Okay, so again, I'm just going to, when this is ready, I'm just going to hide some of these. Yay. And let's do the first thing that it says in Alex's little information. Alex says, we did this part, right? And by the way, this should say Tsiliopoulos@hotmail.com. I'm going to change that later on if you got it wrong, okay? Either way, if you send it to this, it'll bounce to my Tsiliopoulos@hotmail.com, so I'm okay. Let's move on. Code requirements. It says in game start, set the play scene as the starting scene. Let's see how I can do that. I mean, that means go to the game folder, the game class, and go to the start method. Okay, let's do that. So I'm going to close all these things down for now. Let's close them down. So close all tabs. And I'm going to go into Singleton's game.cpp. And I'm going to change the scope from global scope to the game. And then from there, I'm going to teleport down to the start method. So you can do that here in Visual Studio just by selecting this one first, the game, and then you can hop to any method that is listed inside of your class. Okay, so I'm hopping to the start method. And here's my start method. It says, so change the start scene to the play scene. So how do I do that? If you guys are following along, how do I change the start scene to the play scene? What do I change? Come on, guys. Help me out. Change scene state. Okay, yeah, we're here. Yeah, change scene state. Then what do I do? It's pretty simple, actually. Put the play scene in. Okay, yeah, exactly what we do. So we go play scene. Okay, and when I do that and run everything, then you can see that when it builds, finishes building in a second, one day, eventually, it starts the start scene. or the play scene instead of the start scene. Yay, we did it. Okay, cool. I want to put this up on GitHub. How do I do it? All right, well, let's go back to my thing. I have some 11 changes that I made. These are all the changes that I made. I want to do a couple things for the changes, right? I want to add a summary, right? It says required. So we'll say we changed game to start with play scene. Okay, so commit to main, right? And then push to origin. That's how simple it is. Let's go back up online and see what that looks like. So if I go back online and if I refresh, you can see now that I have 3 commits. And my third commit is change game scene to start with play scene. Make sense? So this is how I want you to work. Every time you add a feature or make a change, push to GitHub, right? Don't just do it one time. Awesome. Excellent. Okay, let's go back. So we did this. We made it work. That's great. Let's do the next piece. So I'm just following along with Alex's guide here. I'm following the instructions. So I've done this piece. Okay, comment out the following existing code. Comment out all the U items in the playscene.h. Okay, let's do that first. So again, playscene.h. Go to the scenes, go to playscene.h, and comment out all of the UI items. Cool, let's comment them all out. Go here and comment it out. Yay, comment it out. Cool. Well, what this will do is cause a problem with your playscene.cpp. Let's go there. Because they've been commented out, all of these things are commented out too. Look, right? So that means they don't exist. I don't have a back button or a next button or whatever. All right, let's go back into that. And I can comment those out too in here. Let's just select all of this and comment it all out up to here. Awesome. Save. And when I start off again, you can see that I've commented it out, all the UI elements in my play scene. Let's see if it works. No UI elements. Okay, let's put this up on GitHub. Bam. I'm going to go back to here. I'm going to go to here to the summary. I'm going to say commented out all UI elements in play scene. This is a long commit, and it'll warn you a lot of times if you make a big commit like this. Commit to main and push to origin. Done. Let's check to see what that looks like and refresh. And you can see that I have 4 commits, and it's done exactly that. Commented out all UI elements in play scene. Okay, cool. Awesome. Let's follow the next thing that it tells us to do, which is, all right, in the start of playscene.cpp, comment out all the code related to the buttons and label. We did that. So we've done this piece. Done. Now, the next part, in playscene.cpp, set the positions of the plane and the player in the start function. Okay, so I'm in the start function. The positions of the plane and the player, how do I do that? Remember what all game objects have. What do all game objects have? I talked about it earlier if you were paying attention. They all have a transform component, which means I have to get the transform component and change the position. So the way that works is this. You say m_p plane sprite dot, and let's just use get transform. It'll change into an arrow because it's a pointer. Dot position, we're going to say is equal to a new GLM vec2 object, where vec2 is vector2, and we're going to position it wherever we want. The plane, let's position it at 400, which is the middle of the screen, and 100. Okay. All right, let's see if that worked, and press play. It's going to be way up at the top now, like way up here. Hey, right? And let's move the player further down. Let's do the same thing with the player. m_p player dot get transform dot position is equal to glm vec2, and we're going to make it so that it starts at 400 and something like 500, like kind of at the bottom. and run it. Hey, look at that. He's way down here and this is way up here. Cool. So that's how you change the position. You change the position by using the calling up the actual object, the game object. You're calling the transform component. You're going to the position. You're changing the position. Notice that there's arrows here because both the position and the transform are all pointers. That's why you have pointers here instead of dots. Cool. Awesome. Let's put that in. Let's put that up on GitHub. So it says here, we're going to go here and we're going to say, changed the plane and player position, right? Let's put that in like that and commit to main and push and done. Okay. Okay. Let's go back online and go to the next one. We know it went. Let's continue. So we did this, set the positions. Okay. In the handle events function, add code to move the player via A and D, as well as W and S. It's too big to push. That's weird, Jesse. I'm not sure why it's saying that. Let's continue and do that for me. So I'm going to go into the handle events function. Let's jump there. Handle events. There's handle events. And notice I have a joystick here. It handles joysticks. When joysticks are greater than 0, it handles all this. If joysticks are less than 1, so it's 0, it handles this. What you need to do is comment out this part from line 40 to line 67. So no care about joysticks. And we're going to comment the top part of this part and the bottom part of this part. So now all we have is the event manager. The event manager, remember, it's a singleton, right? It says, hey, event manager, go through my instance function, check if key down is scan code A. Hey, event manager, go through the instance singleton function, check if the key down is scan code D. Okay? And then let's see if this piece works by itself, if I can actually do the animation to move my, my player right or left. Let's run that. So again, if I press the D key, I can see I'm using the animation to move right. And if I press the A key, I move the animation to do left. There is no animation, my friends, for Mega Man to go up and down. Okay, I haven't put that together. So if that's true, and if I want to move the player right and left, how do I do that? Well, we know we can get the player's current position, right? And the way to do that is let's use an auto, a variable. So we'll say auto, we'll call it current position. My current position for the player is equal to my m_p player dot get transform dot position. That is the current position of the player, and the position is a GLM vec2 object. Okay, so that's the current position. And then what I want to do is I want to add some value to it when I press the button. Let's do that. So I'm going to say m_p player dot get transform dot position is equal to a new GLM vec2 object. So let's do current position first. Plus, we'll add a new GLM vec2 object to that. And we want to move left. So I'm going to say -5 and 0. So what it's going to do is going to subtract 5 from the X position of the current position, if that makes sense. And it's saying, hey, Resharper is saying, you may want to add a const because this current position is never changing. I like that. So I'm going to do that. Let's run it and see if we can move to the left. So move to the left. Hey, I can't move to the right now. I can only animate to the right, but I can't move to the right because I haven't enabled that functionality. Let's do that next. So grab all this, copy it, go down over here, paste it, and then let's change this from -5 to +5. Hey, This is brute force, by the way. We could probably do better than this, but we don't care. We just want to make it work for today. All right. Cool. Awesome. Well, let's do some copy pasting. If I did this and copy pasted, if I know I can do this, let's do this. And I really know a couple things. One, I don't have an animation, so I don't need this part. I can get rid of this part. Not for, for up and down. For up, I want to use the A key, right? Or sorry, the W key, I'll be okay. And for down, copy paste. For down, I want to use the S key, right? So W key to move up, S key to move down. But I don't want to move on the x-axis. I want to move on the y-axis. So what do I put in here? If I want to move 5 pixels up, what do I put in here? What number? If I want to move 5 pixels up. Rakib says 5. If I put 5, actually, that's going to move me down. Because remember, when I start drawing in SDL, right? What I'm actually doing is the 0, 0 point for SDL is the top left corner of the screen. Remember? It's 0, 0 is here, right? And because 0, 0 is up here, we count X to the right and Y down when we draw our screen. That means if I want to go up, I got to go negative Y, right? Which is kind of counterintuitive to us. So if I'm going up, I need to go -5 here. Okay, don't worry about Rakib. And that means I'm going to go +5 here. This is all learning. So we learn by doing. There we go. And let's check this out and run it and see what's happening. So if I run it, if I go up, I can go up now. He doesn't really animate, and I can go down, and I can go right, and I can go left. Cool, right? But I can't go diagonal. Why? Because of the way I've positioned my conditional statements, right? Else if means either one or the other, but not both. Well, I don't want to do both left and right, and I don't want to do both up and down. I want to do either or, but I want to do them separately. So I'm going to take this conditional statement, cut it out, and and I want to go down here, right below this set of conditional statements, and put in the new ones, and change this else if to an if. Now I can do both. I can do both left and right and up or down. Okay. Just going to tab over to make it pretty. And let's run it. Let's see how that works. So can I move diagonal? Yes, I can. Right? I can move diagonal down and up and down in all 4 directions. Yay! Cool. I've satisfied another condition that Alex has asked us to do, which is handle events function and write code to move A and D and W and S. Cool. All right, let's go and put that up on GitHub. So I'm going to say added WASD movement for player. Commit to main, right? And push origin. Awesome. Okay, are you guys with me? Check mark if you're with me, X if you're not. You should be starting to get it at this point. Okay, I've got one not with me, and that is Thomas. Thomas, talk to me. Why are you not with me? Rakib says, couldn't you set the up and down animation to just be the left or right animation, depending on which way you are facing? Yes, you could. You can't keep up. It's okay. The great thing about this, Thomas, is I'm recording everything. So you can always go back and look at the recording and submit this by Sunday. It's due Sunday at midnight. Okay. All right, awesome. So I've done this, and Rakib says, hey, why don't we change the animation? Can we add some animations for the other stuff? Well, where are these animations anyway? As an example, Where are the animations? Let's go to player set animation state. Let's go there, go to definition. And you can see in the player, I have a couple of animations that I've done, right? I've done a run animation and I've done an idle animation. But there is no run up animation or run down animation. I could do it, but at the end of the day, what ends up happening is it'll still run up, it'll just look to the side when I'm doing it. So you could do that for sure. So if you want to, let's do that since you're asking, and you want to modify that, let's do that. So we'll say that when you're running up, depending on which way you're looking, depending on which way you're facing, right, then we'll run up or we'll run to the right or run to the left, depending on which way we're facing, right? So we'll leave whatever way we're facing here, and we'll just change the animation state depending on what's happening. So I'll say that if the animation state is false, if run right is false, then we'll do something. Otherwise, we'll do something else. And we'll do that in here, in this area here, right? So if this is triggered, one of these two things is triggered, there's going to be some duplication, guys. I'm so sorry, right? And it tells you that, look, if M player facing right, then set the animation state to player idle right or player idle left. Well, we kind of have this thing here. And what we're going to do is we're going to kind of copy paste this just for Rakib, right? But instead of player idle right, we're going to say player run right, player run left. So player run right, player run left, right? And then we're going to do the same thing. We're going to duplicate this, and we're going to put it down here. Ooh, there's got to be a better way to do this. There's got to be, because this sucks. This is terrible, redundant code, right? And there is better. We're not going to do better today because we have no time. All right, cool. So let's try this out now. If I run, you can see I'm facing to the right and to the left, and you can see whatever we're going, it's going to continue to animate no matter where we're going. This is just for you, Rakib. All right, so that's cool. Awesome. That's excellent, right? We've got it working, and we satisfied another one of these requirements, right? So we've got this part done. Next, let's move using IamGUI to move the plane around with a slider. IamGUI to use a plane around with the slider. Okay, cool. Where is the IamGUI function? Well, if you go here, you can go down to the UI function, the GUI function, and the GUI function is down here, and I've already given you a slider. Hey, look at that. All right. Let's change the slider to plane position. Okay, so that's what it's going to read. It's going to say plane position. And to show you this first, let's see where the slider is. Couple things. Remember, we can get to the IamGUI thing by pressing backtick, right? That backtick character, right? And that backtick character is the same character just underneath the, so backtick is what it's called. And it's underneath the, it's underneath the escape key, under the escape key. Okay, that's where it is. So if you press backtick here, you can see that it'll pop up and come down. Tilde without shift, exactly. All right. So now we can see that it says plane position. So when I've changed this here, it kind of, highlights that in the position. One thing to note, this is a float 3. That's what I've made it. And I've got X, Y, and Z coordinates. Well, we don't need X, Y, and Z. Let's make this a float 2. So say float 2. And we also want, we don't want to just start off in 0 and 1. We want to start off with the plane position. So we can say something like, m_p plane sprite dot get transform dot position dot x and m_p plane sprite dot get transform dot position dot y. Oops. And that, my friends, is how we can get the initial position of the plane inside of my slider. We want to pass a float 2. We've changed the name from a float 3 to a float 2. So let's rename this to float 2. And we want the plane position to go from 0 to 800, not from 0 to 2. That's a range that we can use our slider, right? And let's change this to float 2 so we can see what they look like. We don't need the third one. So let's see if we change the slider now, do we get values that make sense? Okay, let's do that. And let's go run. Okay, awesome. Let's look at the slider. Backtick, right? So backtick brings up the slider. Hey, look, 400 by 100. Oh, man. I got a negative there. Why is that? Why? Because I made it a float 3, a slider float 3. I need to make it slider float 2. That's the IamGUI object. Let's try it again. There it is, right? And if I change these values, take a look at the console. If I change these values, then the values change here, which means I can affect the game by changing these values because I can do something. I can show changes here. These things are linked, right? So that means I don't need this anymore. I just have to use float 0, float 2 0, and float 2 1. So how do I do that? I can say, well, m_p plain sprite dot get transform dot position is equal to a new GLM vec2 object where we're going to use float to 0 as the x and float to 1 as the y. And when we've done that, it's going to change the position of my plane, right, according to when I change my slider. Let's try that. So run it. And backtick. And woo, right? Oh, wow. This works great. Okay, cool. Okay, we've satisfied another requirement from Alex. We've done this part. Okay, let's say that we can move the plane with the slider. Okay, so going back to GitHub Desktop, we're going to say enabled slider. We'll say IamGUI slider to move plane. Commit to main, push to origin. Awesome. All right, go back. And so we've done most of it. Yeah, here it is. Here's your code. All right, so let's think about what's happened here. We know that whenever we access the plane, we can get to, through its transform, the position property. Why? Because if you look at components, right, let's take a look at the transform. You can see that the transform component has position, rotation, and scale. All game objects, we said that, right? If I go to core, and if you look at game object, all game objects have a transform component. So therefore, all of them have a position, rotation, and scale. And we have getters and setters that allow you to get access to the position. So get transform, and we also have a rigid body. A rigid body is another type of component we're not going to handle right now, but it also has mass, velocity, acceleration, and is colliding. We're going to use this when we move things around, when we do not just pathfinding, but other things. Make sense? Awesome. That's fantastic. All right. So we've satisfied most of the requirements. Now the last one is up to you. The last one is up to you. And the way it's going to work is this, right? It says, when the distance between the player and the plane are close, your discretion, you're going to show the end scene. You're going to transition to the end scene when the distance between the player and the plane are close. Okay, first of all, how do I transition to another scene? We have some of this code already, right? If I go to the playscene.cpp, the code that we commented out has that code in it, right? When I press the next button, you can see that I'm using the game instance change scene state to end scene. So there's part of the code right there. We can change the scene by calling the game Singleton, accessing the change scene state method, and putting in the scene we want to go to. That's one thing you need to do. And this is your own code. Next, how do I detect if they're close? Well, Alex says, check the collision manager. Okay, where's the collision manager? Well, that's under managers, collision manager. Under the collision manager, we have a bunch of functions we've included just for you. One of them is squared distance. Squared distance takes two parameters, P1 and P2, which are both vector 2s, position 1 and position 2. Collision manager is not a singleton. It's a static class, a different way of doing things, right? What you can do is you can say, hey, collision manager, I want to access the squared distance function, and I want to pass in the position of the plane and the player. And it's going to return an integer, okay? And what squared distance it does, which is different than a regular distance function, is it doesn't use square root, okay? It doesn't use square root. Square root is actually computationally expensive to use every frame, right? So if you look at go to definition, you can see what it does. It takes the difference of x's and the difference of y's and then squares each of them. So squares the difference of x's, squares the difference of y's, and then returns the result. What this means is if your distance was 5 pixels, you're going to get back 25. Okay, that's what it means. So you need to come up with a function if you're going to use squared distance that gives you if it's close enough. Is it less than 25 pixels? Is it less than 2 pixels? What's the number that you want in order for you to know to transition? It's almost like I want to collide. I want to go to the next scene if I'm close enough to collide. Okay? That's squared distance. But there's also one more function I want to show you that you can go to. If you go to core and if you go to util, there's another static class, util, which has a bunch of math functions. And one of them is the distance function. There's also squared distance here. I've kind of added it both places so you can do different ways. So distance, if you go to distance and if you go to definition, it actually does square root distance. So Pythagorean distance between vector A and vector B. So either way, you can use util distance or you can use collision manager squared distance to calculate the distance between the two objects. Okay? Now remember, you need to do that every frame. Where would you need to do that? You can put it in update. Okay, that's what it says. So in update, if I go back to here, and let's go to the update function. So again, I want to go to the play scene, and I want to go from the play scene to the update function. Notice update, all it does is update the display list. So there's two things you can do here. You can add another function here. So you can add another function here, or function call here, your own function, or add code directly here, and it'll run every frame. It'll do that distance check every frame, okay? And when it's close, transition to the previous scene. Make sense? That's on you to do, all right? Okay, that's it for me. I'm going to save, and I'm going to exit Visual Studio 2019. And I want to talk about one more thing that's very, very important to do. Remember that up online, when you look at your content, there is a couple things we're going to require from you. If you go to week 1, right, for your lab 1, I'm just going to put this in here so you guys can see it. In your lab 1 requirements, it says, it talks about the square distance. So submission requirements is a working link to your GitHub repo, and it says other requirements TBA. We're going to need you to submit a completed lab report. I'll show you the lab report in a second. And also a short video on your own, 1 to 5 minutes, that demonstrates the features, required features. That's all you need, okay? And notice that I've also included a lab report here. The lab report, if you look at it, and I've kind of downloaded it already for you. So there's downloads. Here's lab report. The lab report is going to include a space for your first name, your last name, and your student ID. Okay. And what you're going to do is you're going to look through some of these things. You're going to mark yourself. You're going to say, okay, cool. Version control as an example, right? You know, do I have version control? If I have no repo, I'm going to get 0%. Whatever you have, let's suppose you have this piece. You have everything, just like I did together. You've added me as a collaborator and Alex. You highlight it. You say, this is the one I got. Okay. And let's suppose your play scene setup you did properly, because that's pretty easy. You did this one and highlight that one. And player movement, you kind of have it, but it could probably use some adjustment. It doesn't look right exactly. You couldn't make it work like me. You know, then you put this one. And IMGUI debug controls, you made your slider controls, but they didn't quite work exactly how mine looked. You put this one. And then finally, you said your distance check. Well, you couldn't make that work at all. Let's just say, right? And this is the way you hand it in. And when you demonstrate, you're going to say, okay, here's my version control. I got my version control. All right, so here's my play scene setup. You can see here that I don't have any, I started with my play scene and I don't have any labels or buttons. My player movement, here's my player movement. I can move WASD and I can move my player around. Okay, here's my IMGUI controls. I can move my slider around. And finally, Tom and Alex, here's my distance check. You can see that my distance check is just not working, or it is working. Here it is. And this is how you're going to do your video. And when you're done that, your video is over. It could be like 1 minute. Okay? It's that simple. Don't make it crazy. Don't overthink it. It's very simple. It can be a YouTube video. Absolutely. I prefer YouTube over everything else. It's the easiest way to do it. You can record yourself through OBS. You can record yourself in any way you want. Okay? Makes sense? That's what's due Sunday at midnight, guys. And that's it for me. You can use OBS. OBS is a recording software you can use, right? There's a ton of tutorials on how to use OBS. You can record your screen. That's all I care about. I don't need you to record yourself, just your screen. Okay, Sam? And I'll put that OBS project in your chat there. No, you don't talk about your code. You just demonstrate the stuff that you're doing. Okay, not for your labs. Okay, now it's got to be your own code, please. When will the recording be available? It's available now. As soon as I stop, it's going to be available. You can always watch it anytime you want. Okay, guys, thank you so much. That's it for me today. How do I find the recording? The recording is up on Blackboard right here. So if you go to week 1, the recording is right here. Getting started, getting to know Sdl Engine. Okay, guys, thank you so much. Really enjoyed seeing you guys today. Good luck, and I'll see you guys next Tuesday. Remember that Lab 1, which is worth 4% of your final grade, is due Sunday at midnight. Thanks so much. Take care. I'm going to stop recording now on YouTube. Take care, guys.